This video is looking at the 2014 higher level question 5, again transformation geometry. So the question is set up here and we've again got 4 transformations. From P to P1 we're told that it's a central symmetry. So P1 has the positions, it's over this way 145 from point P and then it's 65 above it. From P1 to P2 is a translation, P1 to P2 translation. P3 to P4, P2 to P3 is an axial symmetry, so here to here is going to be an axial symmetry. And then finally rotation clockwise through 90 degrees from P3 to P4. We're asked to draw the given figure and then we're asked to determine each image under each of the transformations, so draw under each of the 4 things that we've just mentioned. Setting up our question here, it's one of the nicer questions to set up. We've got, it's based on a square first, so this bit here is based on a square. This line and this line here are at 30 degrees, and then they're out parallel 25 millimeters from here, gives us this line coming down the side. And then the circle, just join the diagonals, and we'll be using that in a while. Radius 16 gives us that bit of an arc there. What I'm going to do next is I'm going to label all the remaining points, so P, Q, R and S, and then I really only need 2 more, the other ones we can find. This one up here, T and U. As I said, the center we don't need to move, as joining the diagonals, joining P to R and S to Q will give us that center point, and we'll already have the radius set up on our compass. So, as it says in the question, the first point from P to P1 is a central symmetry. So P1 is not the center symmetry, it is where it ends up. So we're going to be taking, starting off this the same way that we start off all of these points. We're going to join from P to P1. So draw a line joining P to P1. And we need to locate our center of symmetry. So the center of symmetry is going to be halfway along the line here. So extend the compass over halfway, bisect, so see an arc, same size arc either side. Can go far enough. And then joining our point, the arcs. This point here in the center, that is the center of symmetry. So I'm going to call it point C. So all our points, all our P, Q, R, S, T and U all have to pass through point C. For each point, the procedure for this is the same. So if I take Q next, Q passes through C. We measure the distance from C to the point being point Q, mark that same distance on the opposite side. This here is Q1. Same thing for the next point, so point R, again passing through C. Make sure they have to go through the exact center. If you start going off with different angles and they don't all pass through the exact point, then this will become very inaccurate by the time we get onto the rotations. So this is R1. And S1. So each point procedure is the exact same. Draw your point through the center symmetry. Measure the distance from the point to the center symmetry, same distance on the opposite side. Gives us our 4 points here, S1. So I'm just going to join these up lightly first, so we can start to see what this is going to look like. So the next 2 points that we have, and the final 2 really, are T and U. So again, it's the exact same thing. Point T passes through the center of symmetry. Measure the distance from the center to the same point on the opposite side. This is T1. And also then taking point U through the point, from point, through the center, out the other side. So procedure exact same for all of them. And this here is U1. So T joins to U. It's important to look back at here at the original to see what joins to what so that you're not making mistakes and joining stuff up to the wrong spot. T joins to S. U joins to P. And then we can darken in the remainder of the outline. Okay, final part of this is we need to locate the center point for that circle. So join our diagonals P to R and Q to S. We had a radius of 16, so point for a compass on where those two arcs cross, and then just draw our arc here of radius 16. And that is the central symmetry done. So the next part of this is going to be a translation. So it's a translation from P1 to P2. Again, with all of our transformations, first thing you do is you join the 2 points together. So P1 to P2, it's this distance. And what's going to happen now with the translation, all points move the same distance and same direction. So the distance that, or the direction that they're moving is parallel to this line. All of them move this direction. So we're going to need our sliding set squares or an adjustment set square if you have one. From P down P1 down to P2. They can take R, that's going to be the same. So coming down this direction. Q is going to be the same. Coming parallel, coming down this direction. And I'm going to do S now as well, just like I did last time. So again, all points move the same direction, so they're all coming down parallel to each other, and they also move the same distance. So we need to measure the distance from P to P1. So if you have a compass, you can do it that way. I don't think mine will stretch that far. So from here down to this, and measure the distance. So we're going to mark the same distance then each time. So again, accuracy is important here. So we've got Q2, R2, and S2 down here. Again, I'll just join these up lightly. Again, we're going to take the remaining 2 points, so that's T1 and U1. So again, line up our set square, so we're going to take our line parallel from T1 off down along this way. Again, same direction, and they're also going to move the same distance. So we've got U2 and T2. So again, joining up the points that are joined together. So T joins to U, so T2 will join to U2. T joins to S. S to P, and so on. So it's important that you just check back every so often, make sure that you're joining the correct lines together. And you should really go in and darken it all. So I know I have some of these lines drawn already and the shape is there, but you need to darken them in so it's a little bit clearer as to what's a construction line and what's a shape. So again, joining our diagonals Q to S, P to R, and again drawing our arc point on where the two diagonals cross. And that gives us our translation. Next part, the third transformation happening in this question is an axial symmetry, and that's from P2 to P3 we've got an axial symmetry. So for P2 to P3, again, we're going to do the exact same thing starting off. You're going to join your 2 points together. So from P2 to P3, just draw the 2 points together. So we need to locate our axis. So our axis is going to be halfway between the line points P2 and P3. So again, just like we did for the central symmetry, take an arc, swing it, extend over halfway, swing an arc. We're just bisecting the line. And this line here is our axis. Now again, for an axial symmetry, like a translation, and for the central symmetry, there's going to be certain rules we're following. For this one, all our points are going to move perpendicular to the axis. So each point moves perpendicular to the axis and same distance either side of the axis. So I'm going to take point Q first, moving perpendicular to the axis, so that's a line parallel to P2 to P3, or perpendicular to the axis. Taking line R and line S. I wouldn't go moving all of the points, you get too many of them together and it just gets confusing. So again, measuring the distance from our axis to the point, from axis to Q2. Axis to point R. So it's Q3 and R3. And finally S. So for measuring from the axis to the point, same distance on the opposite side, S3. Again, lightly join these up so you can start to see what I'm looking at. So that gives us the first part there, that's our square. The next piece then that we're going to do is again taking the rest of the lines, so make sure these are all going parallel again, or perpendicular to the axis, parallel to the line P2, P3, and then point T as well. So again, measure the distance from the axis to the point, same distance on the opposite side. From the axis to the point, same distance on the opposite side. T joins to U, U joins to P, T joins to S, join the diagonals to locate the center point for the circle, or for the arc. And again, draw our arc, same as we've been drawing up to now. Okay, and that's our axial symmetry, so we've gone, all these lines have gone perpendicular to the axis, and the distance from the axis to the point is the same distance on the other side. So the final part of this question is the rotation. And the rotation, so it's clockwise through 90 degrees from P3, which is here, to P4. So it needs to go clockwise. So again, first thing we're going to do is join P3 to P4. And what we need to do then next is work out where our center is going to be. So to work out where your center is going to be, we're going to work on either opposite sides of this line. So if you put your finger down on, let's say, this side of the line here, and move from P3 to P4, it would swing this way, swing that way, so up along this way. Is this going clockwise? No, it's not going clockwise. This is going anti-clockwise. I put my finger down on this side now, and I will swing this way, because that's the way the arc will go. Is this going clockwise? Yes, this way is going clockwise, so from P3 to P4 clockwise, my center is going to be off out over on this side. So the angle that our center is going to be off out over on this side, our angle that we're told is 90 degrees. So what we're going to do is we're going to create a triangle. So up here is P4, down here is P3, we have a line drawn between the two, and we're going to create a triangle. So for this triangle to work, two sides need to be the same. So this side and this side must be equal length, because the point of our compass is going to go here. So they're essentially radius distances. If this angle here is 90 degrees, 180 minus 90 is going to give us 90. Divide that by 2, I'm left with 45 degrees. I'm dividing up by 2 because I've got this angle and this angle. Both of those angles need to be the same. So 180 minus this 90 over here leaves me 90 degrees for this angle and this angle. Divide by 2, 45 and 45. So taking our protractor, point for compass on point 3, P3, and I'm going to measure a 45 degree line here. Do the same thing on from P4. So again, 0 is lined up on the line joining back down to P3. Again, measure 45 degrees up this way. And where these two lines cross each other, this point down here, that's the center of rotation. To confirm that it's correct, put the point of your compass down on the center of rotation, and you can just swing an arc up along that way. It's off P4. The angle here is 90 degrees, so we have this correct. So this distance and this distance must be the same. If it's not, then your arc isn't going to work out correctly. So what we're going to do now is we're going to take each point on its own, so take each point individually. So the process for each of these is the exact same. The point joins the center, you measure an angle of 90 degrees because that's the angle given in the question, then we swing the distance from the center to the point onto the new line. So step 1 is joining the point to the center of rotation. We then measure an angle of 90 degrees around that center from that line that we've just drawn. So point Q4 is going to be up along that line there somewhere. How far up there it is going to be determined by how far it is from the center. So measure from the center of rotation to Q3. Same distance to Q4. This point up here is Q4. I'm going to repeat this for the 4 other points. So again, same process, same procedure. Join point R3 to the center of rotation. We're going to measure an angle of 90 degrees. I'm just going to extend this so I can measure it with the protractor properly. So onto our line, make sure we're measuring 90 degrees. 90 degrees is up here. Again, draw from the center out through that line, so R4 is going to be up on that line there somewhere. Measure the distance from the center of rotation onto point R3, swing that onto the line for R. This point here is R4. Continuing on with the same process, so joining the center of rotation to point S, this line here. Measure our angle of 90 degrees. So it's the same thing over and over again. So up here to point 90 degrees, center rotation out through that point there. Measure the distance from our center of rotation out to point S. Swing this distance up onto the new line that we've just drawn. That's 90 degrees. This point up here is point S4. Just like with our previous ones, we can join these up again just lightly so we can see what we're doing. So R and S, R and Q. Q and P, and S and P. So final part of this, then we've just two more points that we need to find. So it's the center from U, so U3 to the center. Measure angle of 90 degrees, same as what we've been doing for the previous 3 points. Measure 90 degrees up here, line from the center out, measure the distance from the center out to point U. Make sure it's on the correct line that you mark it. This is U4. And finally, we have one more point here that we need to locate this way. So joining point T to the center. Measure the angle of 90 degrees. Measure distance from T3 from the center, mark that onto our new line, that's T4. And again, we can join up our points the way that everything's supposed to be joined up. So T joins to S, so T4 here is going to join to S4. U joins to P, so U4 joins to P4. T joins to U, just like they have for the previous 3 images that we've drawn. And then we can darken in the rest of our lines. So again, just join the diagonals. P joins to R, Q to S. That locates our center. And then we can draw in the arc here. And that finishes out this question. A few things just to watch out for with this question and with this type of question in general. When doing central symmetry, all points must pass through the center. So this center symmetry here, if they're starting to spread all over the place and go slightly wide, then it's not going to be accurate. Especially for this being the first transformation, by the time you get to here, if you get the first one inaccurate, this is going to be all over the place. For a translation, again, all our lines are going parallel to each other. Make sure that they're all parallel to each other so that it's nice and clear. Axial symmetry, the same. Make sure they're going parallel to each other, perpendicular to the axis. And with our center rotation, again, accuracy is important. This question is probably the one where accuracy is most important, as if one small mistake up here will transfer through and probably get progressively worse. Final thing is presentation on your page is going to be important. You can see here we've got the outline of this drawn in so that it's possible to distinguish between what's a visible line, what's an outline line, part of the object, or axis or something important compared to what is a construction line. So these lines here, they're construction lines. They should be considerably lighter than the rest of the object, but they should still be on the page.